Hey everyone, welcome to the 13th Ship It session where we try DevOps agents. Noor and I, Noor, my colleague and like leading DevRel at Stakpak, and I'm the founder and CEO of Stakpak. So what we do in every Ship It session is we take agents and we try to do stuff with them. Today the format is a bit different because we have a lot of things like a couple of announcements we want to share with you. And we're going to walk you through something cool we've been working on the past couple of days. So yeah, so here's the agenda. So first, we want to announce that we're like, as you know, like Stakpak, the CLI agent is open source on GitHub. It's built in Rust, and we're going to join Oktoberfest this year. So you'll be able to contribute to Stakpak. We have like prepared some issues for you to join. So you can contribute to this, you can contribute to the future of building like AI for DevOps. At the same time, you can learn about trust and building agents yourself from scratch with these issues. So these issues, like there's a wide spectrum of issues. Let me show you how they would look like, or like some examples. So here, okay, yeah, infinite screen. Okay, so you'd see there are some issues that are tagged with Hacktoberfest. So if you filter these labels with Hacktoberfest, you'll see everything in scope. So some of them are about like testing Stakpak functionality on different platforms, which are easy starting items if you don't want to get deep into code yet. But other things like this task, which already someone got assigned to once we posted it, which is adding like third-party MCP servers and extension. These are more like full-fledged features. But there's also some stuff in between, like being able to extend local search through code bases, or like creating a guide or documentation on how to do some stuff with Stakpak, how to install it on different machines, or running more unit tests, for example. So there are a wide variety of tasks, and we will keep adding stuff. So yeah, you can join, and whenever you make contributions to Oktoberfest, um, you would get some swag, Oktoberfest specific swag for your contributions. So it'd be great. So here you would see, like, I'll add this QR code on the screen. You would see it like on the top right corner. You can scan this to find the GitHub repo, and then you can check the issues to see, yeah, what we're up to and like what you can work on contribute. And then next, I would want to show you, like, we want to like announce a couple of features we've been working on. I think you'd find very interesting. The first one is we added Cloud Sonnet 4.5 support, and it's been very interesting. So far we've been getting mixed, like some stuff already, like we optimized for Claude Sonnet 4, which is perfect for it. But other things, we found that Claude Sonnet 4.5 is actually more comprehensive when it comes to analysis, like analyzing stuff and working on tasks. It's more committed and it's less chatty, which is a lot of which is most of the feedback we get from people is like we need to make the model less chatty, and Claude Sonnet 4.5 is already less chatty, so it's more direct to the point. So we see like Anthropic is starting to make Claude sound more like GPT-5, like more robotic, more to the point, and more like mechanical when it comes to executing tasks, which is more efficient. Another thing we added is tool batching. I'm going to show you how this would look like, because this is something like you can easily imagine, but like we started making like Stakpak focus more on batching tool calls. So you would have to approve tools, like review multiple steps the agent would take before the agent would take them. So instead of having to approve every single step, which is something very important for security, so the agent wouldn't break your infrastructure. Um, but now you'd be able to batch these steps, review them at once, and then execute them. So this has two major side effects. So the first one is you'd be able to review like or hit like enter less and be able to see like the high level, like multiple steps ahead and approve them, which is more efficient. So you finish the task in fewer tasks. At the same time, it makes the token consumption much, much more efficient. So instead of the agent having to do inference or call the LLM multiple times, it'd be able to get things done with a fewer number of LLM calls. So this would make sure you have you pay less for the tokens. At the same time, the context window will get diluted quickly. So to give you an idea of how this would look like, I can actually show you an example. So this is my canary test for the steps an agent would take, which is trying to Dockerize this like standard application or like simple fast API application. So it's here, like if I start Stakpak, let's select a specific profile and then ask it to Dockerize this app. So I'm sure you've watched me, like we have videos on YouTube, me doing this task before, but now you see how it's done differently. So as you can see, like in the first step, it reads the rulebook with like the standardized Dockerization official rulebook on how to Dockerize applications effectively, starts exploring the file system all in a single LLM call. So it reads the requirements file, the entry point, the environment, like the environment variables required in the database, all in a single LLM call because it batches tools. And then, as you can see here, it will already start Dockerizing the app in the next step. So it does all the discovery for the application in a single step, but then, yeah, it starts already generating a Docker file with security best practices. It generates Docker git ignore, Docker ignore, and a Docker compose file. You can, like, this is the new view we expose for the tool reviews. So let's go full screen here. So you can see, like, you can scroll with your trackpad or with your like arrow keys, the multiple tool calls the agent's going to make. And you can like reject some of them or approve some of them. And this is like the whole high level approval. But then when you hit enter, bam, it will just do all of these calls in like sequentially, which helps the agent compress a task to make fewer LLM calls. And now, yeah, it's just already building. Okay. Yeah, I think we found a bug. Yeah, that's why we love testing these things live, because there are bugs. So yeah, start building. So I'll keep this going until it's done, because now, like with this approach, instead of having the LLM make like 30 LLM calls to Dockerize an app, it brings this down to 10 and sometimes even 5 LLM calls, and that's it. Because now Stakpak is compressing as many tools as possible within every inference step, and it still gets the same quality and the same results, but with much less like inference time, which speeds things up really dramatically. So I would argue that like Stakpak is now like the fastest, like one of the most fastest, if not the fastest agent with this model in its category. Like I mean, not even in its DevOps category, but like in all coding agents, because of this new batching technique. So it's super fast now if you compare to Cloud Code or any like the existing coding agents, because of how it batches two calls. Yep. So yeah, this is the third part, the tool batching. Another thing we did is reversible tool operations. This is very important to enable you to be able. So we found a lot of users editing multiple files and configurations on their local tools or on the local machine and on remote SSH machines. And in most of the DevOps or operations use cases, you don't have Git on these remote machines. So you don't have Git for the entire file system. The only way of dealing with this is backing up the whole file system and restoring it later on, which is super slow. So what we did is we changed all our file editing tools to be reversible. And to give you an idea of this, let me start an example here. So you guys spin up Stakpak and then create random
1
text
second,
file.
George. They can't see your screen.
Okay. Yeah, here. So I'm starting an instance of Stakpak, and then I always create a random text file. And all of this is open source. I mean, you can check the source code behind how this works in the repository. So it does it like creates a sample file. And then what we can do now is we can ask it, okay, edit this file to add a timestamp, for example. And what it see is like how Stakpak edits file, there's string replace operation being done here, that's the timestamp. And after the timestamp is actually run, you would see like the output of the tool call. Instead of outputting an empty string, it outputs a git style like udiff. And this can be used later on to reverse the diff operation. Because not all string replacement operations are reversible. There are some edge cases where this can happen. So this means like the string replacement operations are reversible. Already create are reversible by default, by definition, because you just add the text and everything is in tool call history. But this as well. And then what we can do next is like remove this file. So we can delete it. So even if you don't have Git, this should also be reversible. So now as we remove the file, you would see there's some metadata in the history, and the file was actually backed up. So there's an original path where the file was, and there's a backup path and a location local, because this operation can be done on a remote server and you can be removing like 10 gigabyte kind of image or file or backing up a database or something, and it's accidentally deleted. You wouldn't want to copy this in like the session. So it's copied, stored like a recycle bin implementation. That's like platform, like that's cross-platform. So the file will be backed up on the remote server. And then from the history, you would be able to restore it. So here you can ask Stakpak to create a different file, restore the deleted file for you. So yeah, to validate that this happened. So here you can see the file, but I can't just get restore the file now. So it found the file in the backup, but it can also could have looked up like the location directly. Yep. And you would see here is we do that, you would see the random text file. So this is how like you make the remove operation reversible. We don't need this anymore. But yeah, so I think the next step would be just like to be able to implement this reversal, so you're able to use this yourself when you're editing files anywhere. Yeah. So these are all the updates. So yeah, back to what we're going to do in the Ship It session. So the agent is still like building and testing the container, so I'm going to switch back and forth between that. I mean, like you got used to us multiplexing a lot while like making the agent do stuff for us. So let me share the terminal again. Okay, here. So yeah, the Dockerization you see, like it's testing the container to see if the images are running, like hitting the health check, creating record, and testing creating post and testing the post is actually created. It's doing all of that in parallel. So instead of before having split that on 4 isolated steps with inference between that can take up to 20 or 30 seconds, it just does it all at once. So this speeds up things significantly. Yeah. So as for today's topic, or what we're going to do is, like, if you remember in the last Ship It session, we built an app with Next.js. And the ideal way to build Next.js, or at least like to deploy Next.js, is through Vercel. But like, again, Vercel as a platform as service, it's super expensive. It ties you in, and it doesn't like Vercel themselves like deploy the Next.js application as a serverless app, but they didn't make it easy for people to do the same on their own cloud accounts. And you want to have ownership of their deployment. And it's actually significantly cheaper to deploy your Next.js app on your own cloud account, as you see now. So what we did is there are a lot of community projects like OpenNext that makes deploying Next.js apps easier on your own cloud. But what we did is we created a rulebook that would help you evaluate how to deploy a Next.js app on your cloud account. We started with AWS, but we're going to add more stuff for Google and Azure as well. And what this rulebook would help you do is help you decide what's the best way to deploy this Next.js application on your own AWS account, and then help you do that. So here I have the Next.js app we vibe coded with Stakpak in the last Ship It session, and we're going to use Stakpak and a new rulebook to see how we can deploy this on my AWS account. So first, let me set my AWS profile here to one of our test profiles, and then we can fire up Stakpak. Okay, so let me deploy this app on my AWS account. So I wouldn't even mention it's an Next.js app. Like, I'll let it figure it out on its own.
What does OpenNext do exactly?
Yeah, so OpenNext help you package your Next.js app as a serverless components, so you can deploy them in a serverless fashion. So this is exactly what Vercel does internally, but doesn't allow users to do this on their own. So that's what OpenNext does. So it's built by the community, it's open source, and it's the base of a lot of the projects that helps you deploy Next.js applications on your own cloud, like SSD, for example.
Yeah, I'm checking now. I think it also works with Cloudflare, not just
so the
AWS.
Yeah, it works with a lot of things, but like the thing about Next.js apps is like they have server-side rendering. And because they have server-side rendering, you can just like build it like a static React app, a single-page web app, and deploy it on a bucket, which is much easier. You have to run a server. And server-side rendering is important for a lot of cases. I'm not like a very seasoned front-end developer, so I didn't dig deep into Next.js before, but there are a lot of complexities in deploying Next.js apps the way Vercel does deploy them, like in a serverless way, where they like the consumption of resources is minimal unless you get traffic, and so on. So we're going to go through this now in the architecture. So what Stakpak did is it read this new rulebook of like how to deploy Next.js apps on AWS and all the different ways. I think it has 6 different architectures with trade-offs and security measures, and this is all free for you to use. And as you see, like since we launched this new batching, so you'd be able definitely to move or migrate your app from Vercel to your own AWS account within the free tier limit of Stakpak. And if the free requests were not enough, you get like 100 requests. But like if you, as you saw, like we can Dockerize an app in less than 10 requests. So if the free tier is not enough, just hit us on Discord and like we'll help you do this again yourself. So here you see like it analyzed the Next.js app, figured out the version that we used. Static rendering and no SSR SSG functions, but like we don't have to do that. Like you can also use SSR, like server-side rendering. Based on the rulebook analysis, there are simple ways. So it got like 4 different ways we can deploy this app, and it figures out that this app is actually like a GitHub, like it's an app to display or like visualize my GitHub profile. So it's something that might not get a lot of traffic. But again, like it's recommended multiple architectures. So the first architecture is OpenNext with IAC. So here are like, I think it broke them down here. So out of the 6 options, it picked 3, but I can also ask it like to enumerate the rest, but these are the 3 best options. And here you see there are like multiple architectures I can use. One of them is actually using OpenNext, the project we discussed, with Terraform or the AWS CDK. With this would cost from $0 because like it says likely the free tier would be enough. So I can even deploy it for free on AWS without having to pay anything. So it would cost $0 to $2 per month, but likely stay from the free tier. The pros here is it has the best cost performance trade-off, and it will support all the features we need from Next.js, and it's managed by infrastructure as code. So it's production ready, it's very maintainable. You can scale this later on if you want. The cons here, it requires some AWS and infrastructure as code knowledge. But again, Stakpak can help you with AWS and infrastructure as code knowledge. And it will take some amount to set up time. Another approach, which is the simplest and fastest approach, is to use an EC2 machine. So create an EC2 machine. It's that simple. You have full control, easy debugging. But then you do manual scaling and no auto deployment, because then you have to configure the machine yourself. And all the different parts and how to scale the Next.js app. And another option is actually to use ECS Fargate, which is an overkill but solid, which is great. Like it has a starting cost because you would have to keep running these approaches for long. But it's enterprise grade and auto scaling, and it's higher. As it like Stakpak detected, this is a portfolio site to showcase my like GitHub projects. So it says like this is a very high cost for a portfolio site. So it doesn't make sense logically. But again, and there's a setup time. And because you start with a cluster and like if there's a minimal setup you have to set, or like resources would be running continuously, they wouldn't be scaling to 0 like in the serverless approach. You can start with 0, like you have to pay something. And again, there's an Amplify approach. And Amplify is the serverless framework. It's like Google Cloud Run for AWS in a sense. So it makes things relatively easier. But again, it has some critical server-side rendering caching bugs that have been unresolved for years on the GitHub repository. So it's not recommended. But you can see there are other approaches here. But as you can see from this, like Stakpak gives you the option based on the rulebook. You can read the rulebook yourself. But it seems like the OpenNext and Terraform option is the best option. I prefer Terraform over the CDK because it's more widely readable and by like DevOps engineers if someone's going to help you maintain this in the future. So and because we get to start from 0 cost, so we get to abuse the free tier. So this is something that Stakpak can help you do like in a couple of seconds by analyzing your project and reading this rulebook. But it can also help you start like implementing this. Again, like it asks me more details about like, do I have AWS credentials configured? Do I have a domain name that I want to add? And do I have a preference for using Terraform versus CDK if I'm choosing OpenNext? So please shoot any questions. Like any questions you have would show up on the screen now on the bottom right. But like personally, I would like to follow like the OpenNext and Terraform approach. I want to use this subdomain george.guku.io, which is the domain I have configured here. So root is in road 53. Create Terraform module from scratch for this. So hopefully, if we have enough time left in in this session, the Ship It session, we'll be able to see this going live. So here's the deployment approach. Okay, so the deployment approach is OpenNext, Terraform with CloudFront, Lambda, and S3 and SEM. As you can see, like there's a lot of services involved in deploying like Next.js in a serverless fashion, which is where the complexity comes from. But then you get like the best architecture you can get for a Next.js application. And yeah, so here it's checking to see what the host zone for the domain is, and then it's doing some research on OpenNext, Terraform, AWS, Lambda, and CloudFront. So it's doing its research to check the documentation to be able to configure this thing. And please ask away while we're waiting. Like we spend a lot of time waiting for stuff to run. So if you have any questions, just like shoot. I'm finishing the Dockerization while we're working. So here you see like the Dockerization, the container is healthy, so it's actually working. And that's it. So we just Dockerize an app while we're waiting. So it's just going to do cleanup. But for reference, I want to tell you like how many requests this took. So I'm going to check here. So it took 7 LLM requests to Dockerize an app from scratch. So this is crazy. That's why I say like the batch tool calling thing is amazing and it's super fast, because it took way less time to do this than you would get from like a regular agent that's not batching tool calls.
Now it's searching in the AWS documentation.
Yes, it's reading a lot of documentation to figure out how to configure things properly. So it's like an information gathering, like research phase before it actually starts coding or like doing any actual work. So I think what OpenNext would do is going to build our Next.js app into components that can be deployed on multiple Lambda functions. I think for caching, serving assets, serving traffic, and the likes. So OpenNext is going to build our project, Next.js project, into artifacts, and then the Terraform code is going to deploy these artifacts in the architecture, in a serverless architecture. So we can make use of the free tier and be able to, okay, something funny happened here. Yeah, it's the same bug. Okay, don't worry, we're going to fix this. So once you get to try this rulebook, all of this will be fixed. Okay, so yeah, so OpenNext is going to build the project into multiple artifacts, and then Terraform code is going to take these artifacts and deploy them in the architecture.
Imagine reading all this documentation manually, like you were
Yeah, it's a
reading.
nightmare. So the issue is not like with the documentation itself, but like because because like you have to configure all these different services. That's why like when Stakpak recommended it, like talked about this architecture, it mentioned that it might be a good idea if you have some experience in the cloud services, but if you're using Stakpak, it will make things easier. So here, like it's running OpenNext, installing OpenNext and running it locally to build the project. That's why I think like Vercel made it super hard to take Next.js and like deploy it serverless on your own setup. So Vercel would be the easy option. But I mean, the community did great by building OpenNext and then like supporting different backends like Cloudflare, AWS, and so on. I think we're going to publish different rulebooks for different backends, so you're able to replicate this on different cloud providers. I think AWS is the hardest one out of them. So the rest will definitely be much, much easier. So it's building the app now. generating the bundles.
This usually takes time.
Yeah, so the OpenNext, the build is over. I mean, the application itself is not very complicated. So now it's checking what's been built, reading the rulebook about Terraform best practices, something I created myself, which is super simple, as you see, like they're just 4 lines. You can customize this yourself. And now it's breaking down the infrastructure components it's going to build. Creating Terraform variables. So you see, like, it's a very elaborate infrastructure. You wouldn't need everything here for a simple app. But let's see. So you have like a server, an image optimization, a revalidation, and a warmer Lambda functions to keep the Lambda function warm. So you see, like, it's the setup is too complicated for a front-end app, but that's because of how Next.js works under the hood and all the features it adds, like with server-side rendering and so on.
It also supports TLS.
So you just run it, but what you do is, like, you need to add a gateway in front of it or load balancer to be able to add like a TLS layer. So this is coded also in the rule book, but you have to build it yourself. There's a couple of other approaches as well. There's another approach in the rulebook that uses an AWS CDK solution package for Next.js application specifically. But like, I wanted to do the hardest thing. Like, I wanted to pick the most flexible, most production ready setup, but there are other options. So it's writing now the code for the Terraform module. There are also a couple of ready-made modules that you can use. But I've met a lot of organizations that prefer creating their own Terraform modules than using third-party stuff. But like, if you're a solo developer and wanted to move your Next.js app, you can just use one of these modules. Again, like, you don't have to do this with Terraform. You can do it with the CDK approach or with the AWS CDK module for Next.js apps. I just like want to have control over everything in the module. So yeah, here I created like 1, 2, 3, 4, 5, 6, 7, 8 files. An outputs file, a main.tf, a lambda file, a CloudFront file, another main.tf. What's the difference between these? So okay, that's a main.tf for the required provider versions in the root module. And then outputs. So created some submodules to be able to use, which is cool. Okay. And a README file. So let's create these. Now it's going to do Terraform init, then validate, then format. This might take some time because it's downloading the dependencies. But yeah, you can try this yourself and have like production ready setup that is super flexible, gives you control over everything. But you can also use like the easier approach and use like the CDK module.
Now, what is it doing?
It's just downloading the Terraform providers. So Terraform init downloads the provider. So Terraform is like the core logic, the state management logic, but you also, to interact with specific APIs like AWS, you need to add the plugin for AWS to install it. And the plugins are binaries that you download. So you take time depending on your internet connection. But then they get cached. So like subsequent applies or like Terraform inits don't take as long anymore. Yeah, I think we have to cut up all the silence and all the time we're waiting for stuff to build to make this shorter. Like things, the tutorials would be much, much shorter if you just like don't wait for stuff.
Yeah.
Let's create a GitHub issue for the tour approval ordering bug we just faced. Maybe someone would be interested in helping us like debug it and fix it on like through Oktoberfest. Because I've hit it a couple of times now. So anyone has any questions about Next.js, agents, bulk tool approval, Claude 4.5?
What do you like the most about new clothes 4.5?
Yeah, what do you think is the difference?
I
Like,
don't know, but like
yeah, personally, so far, like I didn't see a lot of difference, except for like Claude 4.5 consistencies. Like it sticks more to the job, and it's a little bit less chatty. So these are only my two only observations. Like I'm not sure. Like tell us what do you guys what do you guys think and what your observations are. Where?
I saw one company claiming that it is 20% better in code generation.
I mean, it depends on how you measure this. Like you can measure this in
Yeah,
like
it's too general.
100 different ways. Yeah. And I mean, like model companies now, like they have dedicated teams on acing benchmarks. So it's like like a benchmark is a good indicator that the model is somehow better than the previous version, but not necessarily better in real life. Oh, this is taking too long. Okay,
It's
now it's
because of the
validating.
internet.
Yeah, it takes a lot of time to download this. Now it's validating. It found some errors, actually. So I found some errors, missing required attribute. And it's going to fix it. At least try to fix it. What is it doing? Yeah, okay, here. So it added the fix and then running validate again. And amazing, it's valid. So you see, like this is Stakpak batching command. So instead of having a step to edit the file and then another step to validate, it just like batches them and runs them together. So it's technically parallel to calling for sequential tasks. And yeah, this is the structure. 4 Lambda functions with IAM. So we have the root module that creates everything and some deployment outputs we need to access the service. In the main, we have an S3, DynamoDB, SQS, SEM, OAC, and like all the stuff you would need to deploy this. I'm not sure like what does OAC stands for. I don't
I
remember.
don't know. I was gonna ask. What is
Yeah.
ACM?
ACM is the certificate. So it can issue a certificate to make the service
No.
available over HTTPS. So CloudFront R53 and CloudFront needs this certificate and then some infinite output variables. I'm not sure what OSE is. I don't know. We can ask it. But again, yeah. So next steps, apply the infrastructure, upload the assets, hashed files for the cache, and then public files. Okay. Proceed,
It's open
please.
access control.
Yeah, I
Origin
mean,
access control.
where? What?
In,
Where?
in
Origin access
CloudFront.
control. Oh, yeah,
Yeah.
interesting. Yeah. So it's doing a Terraform plan.
Lots of abbreviations.
Yes. Apply. I mean, it's being too cautious here. It's not applying. Like after that, okay, please apply. Okay.
I think it's a new model.
Yeah, it definitely feels safer. Like Claude 4.1 didn't hesitate to apply. A lot of resources are being created.
This is gonna take time.
No, this would have, like, I'm now imagining myself writing this from scratch. Like, it would have taken ages. I mean, figuring out the dependencies is a pain on its own. And something nice we can do actually is, like, if this module works well, we can actually like refactor it a bit and then publish it. And then whenever, like, and link this to the rulebook. So whenever someone is building this, they wouldn't have to write all the code and validate it themselves. They would just pull the module. And we can maintain the module with Stakpak. So this would make it easier for other people to like use this in the future. So there's a lot of things you can do to improve this, speed things up. But yeah, this is if you're creating everything from scratch. So it's deploying multiple Lambda functions. And if you're not familiar with Lambda and the serverless concept in general, it means you get compute that works on demand. So whenever you get a request, you spin up the compute, you handle it, and you pay for the number of seconds this compute has been running according to like the memory and the CPU this Lambda function is using. But when there's no traffic, this cools down and you're not paying anything. So this comes at the benefit is like you can have massive parallelism. You can handle like thousands of users concurrently because they're not limited to a specific machine. And you also don't pay if you're not using stuff. But at the same time, Lambda suffers from a cold start issue. Sometimes it might be slow if there's not a lot of traffic frequently hitting your server. But that's why there's a warmer function that can keep the other functions warm, running on a schedule. So there are ways to optimize this. But yeah, again, like choosing between Lambda, using something like Fargate ECS, or a virtual machine and a dedicated node, depends on your workload and what you're trying to do. Like there's no best solution, because if this Lambda function is going to be being hit a lot with traffic, constantly being hit with traffic 24/7, then actually Fargate would be cheaper. And in some cases, actually a virtual machine would be even cheaper than Fargate. So yeah, it really depends on your architecture and what you're building. For something like this, which is a front-end app, which you just hit it when you load the assets and then it keeps, it just uses the cache later on. It's very efficient and very cheap to deploy this on like a serverless setup. Now it's creating the CloudFront, I think, distribution, which would take some time. But this is basically like Cloudflare version, like the AWS's Cloudflare. Like this is the CDN where all the caching would happen, where the TLS certificate would be served. And after we're done, we're going to check how many requests this took to see if it fits squarely within the free tier. And if there's anything we can do to speed things up, like publishing this module. Still creating. So yeah, this is deploying an Next.js app on AWS the hard way, but so far it's not that hard, really. Like I was really scared.
I mean, we didn't face any bugs, so
Yeah, we'll see. Like we still haven't uploaded the assets and we still haven't like opened up the website on the subdomain we chose, but we'll see. Like so far it's developing, coming up nicely. And again, like every ship it session, I never tested this before. So that's why I'm still waiting to see what's going to happen. So I tested the rulebook in terms of like the correctness of the cost calculation and the suggestions and the trade-offs and the arguments for different architectures, but didn't test the actual implementation of the architecture. CloudFront is very, very slow. And because we use Terraform, it would be super easy to tear this down. You just do Terraform destroy, and the whole thing like goes poof, like it as if it never existed. Two minutes of silence waiting for CloudFront feels like an hour.
It is taking so long, yeah.
Yeah, because like CloudFront is a distributed system. Like it's like CloudFront is a CDN like across multiple data centers all over the world to serve this content like with low latency. So it makes sense that this takes a lot of time.
Why do you think it's gonna be easier to do it on the other cloud providers?
Yeah, because AWS is super complicated. Like we did this last week and the Ship It, the 12th Ship It session, using Cloud Run, Google Cloud Run. It was actually much, much more straightforward. There are fewer services involved with Cloud Run.
But I think it will be the same if we used Amplify.
Yes, but then Amplify also has issues, like what Stakpak mentioned. Like there are a lot of caching issues with
Yeah,
Amplify.
the cache.
And if you saw the cost trade-off, Amplify is actually more expensive than this approach. Wow.
Well,
Yeah, it
can
got
we try?
deployed. Yeah, let's see if it's actually working. Okay. So it wants to upload the okay, so it wants to upload the assets first. Okay. Go for it. So synchronizing the assets, this can be done in the future with a GitHub action. If you have time, you can actually do this also today. But for now, yeah, it's going to get out like the bucket names and then upload the assets. So these can be served by the Lambda functions when we hit the URL. So yeah, here it's syncing the OpenNext built assets with a bucket. And what is this doing? So must revalidate. And yeah, I think it's like, yeah, it's like, I think here it's trying to, for example, like ping the cache or like make sure it invalidates the cache, maybe. Yeah, it's my first time doing this, so I'm not sure what's going on. Like, let's see what's going on. Like I've read theoretically about like deploying Next.js apps and AWS, and I always thought it's a pain. But yeah, here what it's doing is it's synchronizing one other thing. Not sure what this is, and then it's curling the website to test. So more synchronization and a curl request. So what is it doing? So I don't know what had happened to the curl. So let me switch to my browser and check the website. Okay, so now it returns an empty null response so far. So it seems it's trying to debug something.
Probably CloudFront.
Yeah, it's figuring it out. Access denied from CloudFront. Is it using the correct region? So what it's doing? So it's listing functions. So it's debugging the setup now. And yeah, okay, it's debugging the setup. So
Europe North
does not
1.
exist. Yeah, I think it's like not all these URLs are shown in all the regions. Yeah, here's the function URL. Server, the image optimization. So it's trying to curl the function directly. And it made a mistake with this command. It's checking the CloudFront configurations for issues. It seems to be getting something wrong with the CloudFront configurations, like the command is running. So if I point to this, like would I see the web, like the assets loading? Okay, so when I point to this, I actually see the HTML, but I don't see the CSS yet. So the assets are there, but there's something wrong with how things are wired up to CloudFront to fetch the other files. Okay, it's debugging. So looking at CloudFront origin, I can see, okay, stop popping things up. I can see the Lambda function URLs are configured correctly. The issue is that CloudFront is returning 403, but when I curl the Lambda function URL, directly it returns 200. The problem is the Lambda function URLs require authentication by default when invoked through CloudFront, but we've set them to none authorization. However, CloudFront might be sending requests in a way that the Lambda function URL doesn't recognize. Let me check the CloudFront cache behavior, or like cache origin behavior. So it's debugging Cloud Run now. CloudFront, yeah. I mean, these naming services are super confusing. So let me check CloudFront caching behavior if there's a mismatch. Okay, what's going on? Yeah, I think we hit the approval bug again. Now I need to fix this. Yeah, these are the URLs. The paths of the distribution. Okay. Oh. Let's see. Yeah, it's checking the resource policies of the buckets and the Lambda functions. Still getting access denied. Yeah, this is very realistic. Yeah, let's see how it debugs it.
It is still none.
So it says the Lambda function says that it requires no authorization, but then CloudFront, you get an authorization issue. So it can be a million things. It's trying to figure it out. So the issue is CloudFront can't invoke the Lambda function. So here you see, what did it change? Okay, it's adding course rules to the Lambda because maybe this is why it's failing. And what's going on here? More course rules to the other Lambdas and then reapplying. So it added more course rules and it's reapplying the configurations.
Hopefully it works.
Yeah, debugging CloudFront is a pain. Yeah, something else failed.
Everything is red.
Yeah, something else failed. So it was not able to update the Lambda function, must have a length less than or equal to 6. 2, 3, 4. Okay. I think it needs to add more methods. Less methods. Okay. I didn't know there's a limitation on the course policy for Lambda functions. I don't know the size of like the number of methods you can whitelist. So yeah, Stakpak is saying there might be multiple causes. So the Lambda function URLs need to allow public access, which they should with authorization none. Or there's a resource policy issue on the Lambda function, or CloudFront need explicit permissions. So now it's going to curl again. So developed some, like Claude 4.5 developed some theories and it's testing them. Okay, I think it came up with something else. So looking at the OpenText documentation, and CloudFront configuration, I see that CloudFront is configured to use Lambda function URLs as custom origins with HTTPS only. This should work, but the 403 suggests the Lambda function URL is rejecting the request. The issue is that the Lambda function URLs as non-auth should work, but there might be mismatch in how CloudFront is calling them. Okay, so what is it doing now? So create invalidation. It's invalidating the cache. I don't think this would do anything. Like, I don't think the errors are cached.
Because it didn't even access it, right?
Yeah, so we hit the bug again. Like, this bug is very annoying. I promise this will be fixed. Because like I'm struggling with it myself. Like, people should be able, like, shouldn't be suffering because of this. It's waiting for 30 seconds until the validation is complete. So one thing you can do, like, or learn about this agent, like if this doesn't work, I can ask it actually to pause, do some research on these issues online, and then come back instead of like keep iterating and trying different things. So if this attempt fails, I'll do exactly that. So it still returns null for some reason. It's trying different things. So HTTPS seems to be working. But yeah, we're trying to figure out the missing part between the Lambda functions and the CloudFront. So what it's doing is getting the distribution, getting the origin configuration. Maybe because it's using HTTPS only. This might be the issue.
Can you prompt it to use HTTP?
It's trying to use the... No, it's like the origin configuration is between the CloudFront function and the Lambda itself. So how like the CloudFront communicates with the Lambda. So it's not like it's not user facing. Yeah, here. So CloudFront is configured to use Lambda functions URLs as custom origins with HTTPS only. But the Lambda URLs shouldn't allow this. Okay. So what is it doing now? Get the full response from the function URL they're actually being returned. Wow. It's getting... Okay, it's trying to check the Lambda logs. Nice. I'm always impressed by the speed. Like the Claude agents are able to generate a script, like a command to check that. So if I had the idea of like I want to check the logs for the Lambda function, then I can see it. So what is it doing? So I came up with a command to check the Lambda logs, and it would have taken me a while to look up this online. So I think this is great. So show module Next.js Lambda function URL server name. It's trying to see the Lambda. Okay, and however, the simplest fix for OpenNext architecture is to remove the trailing slash from the Lambda function URL. Okay, I think it's onto something. So the problem is Lambda function URLs with authorization type none only allows direct browser client access, not programmatic access from other AWS services like Cloud Run. Okay, so CloudFront. So CloudFront's requests are being blocked at the Lambda service level. The solution is we need to use CloudFront origin access control or switch to API gateway as an intermediary, or use Lambda Edge instead of function URLs. However, the simplest fix for OpenNext architecture is to remove the trailing slash from the URL function domain name in the CloudFront origin. Let me check the configuration. So there is a trailing slash. There is a trailing slash. So this is interesting. Like I didn't know that. Like, let's see if this would work.
What is a trailing slash?
The slash at the end of the URL, which
It is causing
shouldn't
a
matter,
problem?
but it does matter for different services. So the slash at the end of the URL, which like the browser doesn't care, but the server, some servers, they can't route it properly if there's an additional slash. Oh, something is on with the... Okay, so what is it doing? Adding permission to Lambda function name, allow cloud service principal, invoke. Okay, so it's adding more permissions, but it shouldn't do that in the... Yeah, use Terraform. So it was trying to do this using the CLI, but we don't want to do that through the CLI. Like it should be in, like if we're using infrastructure as code, we should use infrastructure as code for everything. Okay, so it's adding other permissions. Let's see if this would make it work. We're almost running out of time. So I noticed something. So Claude 4.5 sets good call instead of you're absolutely right, which is a huge upgrade from my perspective. Like saying good call is much better than like the notorious you're absolutely right. I'm not sure if this fixed the issue. Still can't access it from the browser. Yeah, there's still an issue. Okay, so let's stop it here. So I just asked it to do more research on the issue it found before proceeding. Because it tried, I think, 3 different approaches.
It is gonna Google it.
Yeah, I'm trying to push it to do some documentation research. Yeah, it's doing that here. So Lambda function URL CloudFront 4.3 access denied integration. So it breaks things into keywords and then go spin off like a sub agent that does research across different like documentation sources. This is great. Like, I mean, the things we'll learn here, we can add this to their rulebook. So it doesn't have to go through this again in the future. Because I think it's very close. Like, It's very close to getting it right. It already configured HTTPS, stored the lambdas, added all the functions, configured the notification to keep the functions warm, and did all the hard part. But like this is the missing piece, and then we can test the things. Yeah, it found some stuff. So here you see like it read almost 900 lines of documentation. Now it's googling stuff specific to configuring OpenNext as an origin to CloudFront. So if you're curious, so far it took 54 requests to get this far. Okay, so based on my research, I found the root cause of the 403 error. When using Lambda function URLs with CloudFront, you have two options. Either set origin access. Wait, okay, I was reading this. So either set authorization type to AWS AM with origin access control or make it public. The issue is that we're using authorization type none, which makes it public, but CloudFront is still getting 403. According to Reb's documentation, when using Lambda functions URLs and CloudFront origins without OAC, the function URL should be publicly accessible with non-auth type, which we have. However, the Lambda permissions we added are only needed when OSC, so we added something that's not actually needed. Solution to remove the CloudFront Lambda specific permissions. Okay, but I don't think this would solve the issue, but fine, like remove the
Yeah, me
extra
either.
permissions. Yeah. It seems the Lambda is public access. I think the main issue is like the Lambda, like is the Lambda serving this stuff over HTTPS? Yeah, it is. Okay. State remove version from server. Yeah, it's removing the extra permissions. Oh, okay. I think we hit the same snag again. Yeah, let's give it a couple more minutes so we're not running too late. And if this doesn't work, we're going to publish another video dedicated to this specific task end to end after we figure out like how to nudge, like how to update the rulebook to make this work. Because as I said, like I'm not an expert at deploying Next.js apps on AWS. So we'll have to figure this out with the agent. And then we'll code this in the rulebook so none of you have to do this again on their own. Yeah, it's deleting the extra permissions. Why did it remove it from this state? Ah. Yeah, I think this needs more work. So I think the rulebook needs more work to be able to figure out this last bit. So what I'm going to do here is clean things up.
Maybe you need a rule book for configuring CloudFront.
Yes, CloudFront is painful. So yeah, this is a good idea. So it's cleaning up the code. Reapplying, invalidating. Yeah. So it's resetting things to a healthy state before this change we made to the permissions. But I think I'm going to wrap it up after that. So we can make the agent smarter at working with CloudFront first with rulebook, because like this is the best setup you can get. Like this is how you can replicate Vercel on your own cloud. So it's very important that it gets this right. We're very close. Like, I really wanted to get this. Okay, so yeah, let's wrap it up here. Or do you want to try another attempt at debugging this?
I want to work on the CloudFront rulebook.
Yeah, I think now we
It became
got really,
personal.
now we got very personal. Now I won't be able to sleep until I figure this out.
What is
And
it
we
trying
also
to do now?
we also found a couple of bugs we need to fix, which is great. Like, this is a win. It's still removing the extra permissions. And yeah, I think this needs more work. We could have used the CDK. The CDK would have been easier. But again, yeah, I like doing this the hard way, because like this is the production ready setup. Okay, so yeah, that's it for today's Ship It. We're going to work more on making the agent smarter and on using CloudFront by adding more rollbooks. And we're going to publish videos on this task specifically. So it's going to be much shorter, with the conclusion of what we reached on how you can replicate the versatile setup on your own AWS account. But you can refer to the last Ship It session to see how to deploy this on GCP. We'd also add rulebooks for these, to make this as like optimized as possible. Like, take the fewest number of steps as possible. Like, I mean, all this investigation we did took almost 60 requests alone, so it's very efficient. We're going to make it even faster. So yeah, thank you all for following up with us today. I hope we all learned something new, and yeah, it's great having you all. So have a nice one. Bye.
Bye.